All right, so today we're going to cover direct and indirect variation. In 8-9, we're going to cover direct variation. And again, my classic example is an example of figuring out how old your dog is. In that example, we're going to talk about the dog years in human years, and we're going to multiply it always by 7 to get the dog's age. So again, the formula for direct variation is y equals kx, where k is your constant of variation. Now I know the word constant starts with C, however, in this formula, constant variation is going to be the letter K. Now, the words, if you notice, it says a direct variation is a function defined by an equation in the form y equals kx. You can say that y varies directly as x. So the order you read it, that's going to be what your letters are. So notice here, they're not using y and x. So again, as you're reading it, y varies directly as x. So the m here is our y, and our n here is going to be our x that we would plug in. So if it wants us to find the constant of variation, I can take my formula, y equals kx, but in this case, it's going to be m equals kn, so I can change it, m equals kn, and I'm going to replace the numbers. So 42 is equal to k times 2. In order to solve for k, you're going to divide both sides by 2. And k is equal to 21. All right, so our constant for part A is going to be 21. Now, they're changing the problem and they're saying find the value of m when n equals 3. So now that I've found my constant of variation, I'm going to use that number in my formula. So again, I can use m equals kn, the modified version of the y equals kx. I can put in what I know, the 21. I'm going to put in n equals 3 because that's what they're giving me, and to find out what m is. And m is equal to 63. So you're going to replace what you know. So again, the wording here is what's important, varies directly as n. So the first letter you would read, or the first number would be the y, and then the second number is the x. Sometimes they also give it to you as two order pairs. So we could set this up as a proportion, and then we could cross multiply and divide. Or you could plug it in as an equation also, and then find your k. So you have two different options. So again, the constant of proportionality, you can also solve it this way. So if they give you two order pairs, you could put it in as y1 over x1, and then the y2 over x2, and then cross multiply and divide. So you can also solve the problems as a proportion. So let's look at example 2. It's a word problem. So it says the amount of interest earned on savings is directly proportional to the amount of money saved. So it says if $104 or $104 in interest is earned on $1,300, how much interest is going to be earned on $1,800? So again, you could set this up proportionally. So you could take the two beginning given numbers, put that in a proportion together, 104 over the amount of money, so 1,300, and then take the blue information, how much, that could be your variable, and then put it over the 1,800. And then cross multiply and divide. So you would get 1,300x is equal to 104 times 1,800. You would multiply that and get 187,200, and then now divide that by the 1,300. And that would give you $144. So that would be the amount of interest that you would receive if you invested $1,800 versus $1,300. So this would be a method you could use the proportion for. Now I'm going to do a couple of the oral exercises with you just to get the hang of this, and then we're going to go on to indirect variation. All right, so let's look at a couple. Now I know the beginning part just says, is it a direct variation or not? But here what we can do is look at it. Remember, the correct form for direct variation is y equals kx. The number, sort of think of the k as like your slope. So the number in front of x is going to be, or in front of the variable is going to be your constant of variation. So in number 1, you can see the constant of variation is going to be the 3. In number 2, I know they're not using y and x, but it's in the correct form, and the constant would be 9. Let's see if there's another one. This one over here, number 4, is also a direct variation, and the constant would be 3.3. So let's see. Let's look for another one that we could do. Let me just go down to the homework. All right, so this is just like we did in example 1. Notice the wording. Y varies directly as x, and it says y equals 9, x equals 54. It wants us to write a constant of variation. So again, remember, the first letter you read, that's going to be over here. Oops. On the left side of the equal sign. Then you could write the K and then the next letter. So now we're going to plug in what we know. We know that y is 9. And we know that x is 54. Now you might be tempted to put the 54 first, so that way 9 will divide into it evenly. But in this particular problem, our answer is going to be a fraction. So then I would get k is equal to 9 over 54, and I need to simplify it. And this simplifies to 1/6. Now, if the words change and they say directly proportional, we could still do it the same way. So again, that was what the last example I showed you. So again, you could show that 150 is equal to k times 6, and then divide both sides by 6. And k equals 25. You're welcome. So that's how you're going to do the beginning part of that homework. Even 1 through 10 on the next one is the same thing. You can just plug it into that formula. Now, the next part, 11 through 16, when you're doing these, this one you can do it as a proportion if you'd like. Or you could take the first two numbers, find the k, and then plug it back in. So you can do it either method. I find it easier if this part of it, you do it as a proportion. So for number 11, you could set it up as 15 over 40. Actually, sorry, the two y's. So we're going to set it up this way. x1 over y1. Or did they set it up? Let's see. Let me do it the way they have it. Sort of like slope. Let's do it that way. So we're going to set it up like the slope formula. We'll put the y's on top, the x's on the bottom, and then y2 over x2. So here I'm going to put in 9 over 15. And then I don't know the y2, but I know the x2. And then I'll cross multiply and divide. This is one way you can do it. You would get 15y2 equals 9 times 40. 15y2 is 360. Divide it, and that'll be your answer. The other way to do these problems is to take this top information, plug it into the y equals kx, find the k first. So for example, you could do 9 equals k times 15, divide by 15. Your k is equal to, divide this both by 3, and this could become k is 3/5. Once you find the k, then again you do the equation again, but this time use this information. Let me do it in highlight. So then this time I would do, I'm trying to find the y. I know my k I just found is 3/5, and this time the x I want to use is 40. And then I'd multiply this. I could simplify this diagonally, and my answer is 24. If I divide this over here, this is also going to give me 24. So you can do it as a proportion, or you could do it by finding the k first and then plugging in the information of the second piece of information. You can do these problems either way. Okay, and then the word problems, make sure you just read it. Notice in this word problem down here, it says varies directly with the height. So this is going to tell you how to put it into the problem. So that is 8-9. Now we're going to look at the inverse variation, which is 8-10.